Alright, we are live. Sorry for the delay. As usual, let me mic check. And the mic is fine, alright. Let's get into this then. Yesterday we got the skybox rendering and we were just cleaning up the code. Let's compile and see where we left off. So that is our progress for up to now. So we've done a fair bit of progress. It has taken us 11 hours to get to this. So let's clean up the code for now and then figure out what the code does, and then we will we will try to fix some of the bugs we have, and after that we have simple bugs like I'm not actually checking the semaphores before deleting objects. So the objects could be used by the GPU, but I delete them anyway. So that causes some kind of like some crashes for me. Example of that is when I maximize the window, it calls it reloads the whole thing and it crashes because I delete the swap chain without actually confirming that the GPU is done with it. Anyways, so yeah, so our update function is pretty simple for now. Update input system blah blah, update delta time, that is our camera. I don't know why the camera would need the delta time, I don't know. And view matrix, we're just creating a view matrix here. Let's make this constant. Okay, we cannot make that constant. Anyways, yeah, so interestingly, what is this? Alright. Anyways, yeah, that is how we update our camera for now. We're just rotating it by delta time, and furthermore, there is a draw. We covered the initialization function before yesterday, so I'm not gonna cover it again. So let's get to the draw function. So what our draw does is to get a single graphics command. Of course, first we update our buffers accordingly. I don't know why this couldn't have been done. Okay. I don't know why we couldn't do this on the update function here, because probably maybe this is called on another thread rather than the same thread as this draw. So I believe this is just synchronizing by acquiring this. So they're using the same synchronization. This is gonna wait until this graphics command is free, and when that graphics command is free, it is going to proceed and update that buffer. So it is using that graphics command as synchronization for synchronization. Let me get the graphics command here, and then we start adding some barriers, binding targets. These are a few simple things really. and then setting scissors, setting viewport, binding the pipeline again, binding descriptor, sets, blah blah, and we are done. Okay, one thing that comes to mind is whether no, nothing really. Okay, that is simple. This code is really simple here. So let's go and see what our concurrency design is actually. So I've just copy pasted this concurrency design from the first example. So uh, I am just using whatever that was designed there. So let's redesign this because I think there are some parts lacking here. So let's see our draw procedure here. So our require command is this. This is our require command. What we do there is to okay require next image. So we get the next image from this swap chain. So it just tells me what the next image is going to be. I get that and then I will proceed. Let's get to this. No, I cannot get into that. Then I do the require here. So I don't know what that is used for. Let's check this one here. So let me duplicate this. How can I duplicate this? Well, open container, copy full path. No, I want a duplicate of this. I want a duplicate of that. But how do I get that? Let's go to Solution Explorer and then headers. Add that one here. Can I reopen it? Why can I not reopen it? I remember you could reopen it in Visual Studio. I don't know. I don't know. What I'm trying to figure out though is that what is this actually this semaphore used for? So here, not there. So here we just pass in semaphore here, and I don't know what it is used for. This submit function here, that is also using the space semaphore. So let's try to actually figure this out. I am kind of baffled here. I don't know. I'm kind of confused. So wait, semaphore. That should be right. That doesn't look that doesn't look right. Uh, let's check our acquire function here. Collapse all that. We don't need that. Let's focus on acquire here. So this is our acquire. What it does is that it is we have a fence there, fence status. We're checking that fence. If that fence is done, we begin our command. So that is what this requires doing. So I believe this is saying that this fence is to make sure that actually the command was submitted, and now we can redo whatever we did last time. So where is that semaphore actually used? We're using this fence pointer here, signal fence. Submit descriptor. So I believe when the submit finishes, it is going to signal this fence, and that is how we're going to continue here. So let's go here and actually read the code maybe. Alright, let's see. Execute giving command list. So this is going to execute the command list. Execute command list. So it is going to wait on these. Wait semaphore value fence value -1. This is going to wait on that, and then it is going to execute the commands, and then it is going to signal the fence, and then it is going to signal the semaphores. So we have a bunch of waits here and a bunch of signals. So in here we have this wait here, which is that, which is that. So queue present is going to wait on the queue submit. That is what we're doing here. So by this right here, we're just saying that you should do your work after this. Okay, so maybe we don't actually need this to be here. It's better to be there. So I'm talking about this wait semaphore here. We actually don't need it to be a member anymore. This not this semaphore pointer. You don't actually need it to be a member. The only reason that you would want this to be a member would be that you don't want to construct every single time, because these are actually sequential. These are running in sequences, and you could just make this a stack variable, and you would just make this execution sequential. Or maybe that wouldn't be correct because the lifetime. So you would delete your, yeah, that wouldn't work. You would delete your semaphore before GPU maybe actually has done the thing that you wanted. Alright. So that is understandable for me, this part. And then we have this one fence here. This fence is for our own use again. We're not going to start any draws, any commands. We don't begin new command before we actually have finished the old one. So that is for that. And what else? What else is being done here? The only thing that is left is this one. So, so that actually is weird. Sorry for that. So yeah, this is the thing that I don't understand. So this this way semaphore, this comes from here, from acquire next image. Let's see what that actually does. It's actually not using this. This is actually not using the semaphore here. Too many pointers. Of course, too many pointers. It is the forge codes, dude. They use too many pointers, Igor. That is their kind of default to go with the pointers. We're getting rid of them, hopefully. Yeah. So I'm trying to figure out what the concurrency design of this code is. However, they're seemingly not using the fences or the semaphores, we're passing them. Get swap chain image next. It returns swap chain. Let's see the rest of the implementation for these, like the implementation on Walkin or maybe the direct 3D 11. Let's see. They're not use. What the hell? Are you kidding me? There's always zero here? What the hell? Come on. That is just weird. Look on VK, next image. So I think this interface is just specialized for Vulkan. what the actual hell? This would cause some bad issues. Like that would be awful. You're setting -1 to an unsigned integer, and then I'm using that unsigned integer as my index in my array. This is trouble right there. And you're setting msignaled false. So I'm gonna wait forever? That's just gonna cause me to wait forever. Same with this. That is some weird code right there. I don't know, man. So yeah. So require image here is going to signal me via this, and then I'm going to submit when this is actually signaled. So sorry, I got disconnected. How would that not wait forever? Igor says that that wouldn't wait forever. From what I understand here is that I'm waiting here on this semaphore, and if anything goes wrong in get next image here, not there, rather here, this would just tell me that my fence is not signaled. This would say. So I would just wait on it, I believe. Am I wrong? Is it actually not what happens? So let's actually go check this code here. That's submit code as well. So let's check the Vulkan version again. Acquire next image. That is this, which I return it. So I don't know why they've done that design. It looks like that they are doing literally nothing on the 3011 version. They literally do nothing. And on the 3012, they just set this index here. I don't know. I don't know. Anyways, so that is what they're doing here. I'm still kinda not sure as to how the concurrency thing works here. So after this scope here, either the fence is actually signaled or not. I believe that is correct, is it not? So yeah, after this call, the fence is either actually signaled or not. So if I'm actually using the same thread for all the rendering, I should be fine without using any fences. So the question here now, the only question here is now whether this draw function is always called from a single thread. Because if that is the case, I wouldn't need any kind of concurrency here. Because I'm always on the same thread, and it always sets it as this call finishes. Maybe it would be better just if they let the user actually decide on the thread safety. Because this is kind of actually weird. VK reset fences. And that is a walkin fence. So this fence is actually provided by Walkin. Acquire next image, and it passes the fence there. P-fence submitted. I don't know about this, really. I'm not even sure if this code is correct. I don't know. I have no clue, but I just know that if this is done, that would be set. However, until this semaphore is actually set, I am actually using. Let's make this snuffler for a sec. I'm using the result of this. So the result of this is the swap chain image index. So I am using the graphics command, and furthermore I am using the swap chains image, the render target of the swap chain that is indexed by this. So maybe I should be waiting on this semaphore right here. Like that doesn't look correct to me. What happens if I just pass null as the fence and semaphore? What would happen then? Signal semaphore. So I'm at the moment just passing a signal semaphore, and this is what's going to happen. And my semaphore will not be. It is passed again to the. It is passed to the walkin. Same with the image index, and the walkin would provide me with the image index after this call, and we'll set that. I don't know, I don't really understand what the actual thread safety of this is. Like, you're signaling me right here, exactly after the call. And what is that? And I'm not even sure if that is a thread safe action that's been happening there. I'm not sure if this is even thread safe. You're just setting a bit here that is signaled. I don't know, pad A, pad B, pad C. Why would you do that? Huh. I am kinda confused. Okay, let's just assume that is correct, then our code is wrong. If I assume that I cannot access that swap chain until this semaphore is actually set, I should be waiting on that semaphore right here. Because what I'm actually saying here is that this I'm returning this swap chain image index, which just signifies that I'm saying that that image is actually available and you can use it. However, it could be not available, as this semaphore could not actually be signaled. So the right thing here would be to wait on semaphore. Is there a wait for semaphore? I don't think so. Wait on semaphore? There's no such thing. So I don't know. I do not know. This code, I know that this code is not correct. This code right here just isn't correct. Maybe I should use a fence here. I need to ask this. We'll ask that. Anyways, so with that said, I would need to. So what's happening here is that right now my swap chain, as I delete it, I'm trying to remove the swap chain. It just tells me that it is not safe to remove it because it is being used by the GPU. So I kind of need to wait on something here. So how should I do that? And what does that actually mean? Let's see the remove swap chain call on the main example here. So they're calling it here on unload. I am not calling it on unload. Maybe that is the problem. It is simple for me to do that. I would just need to add one more interface, which I believe I added once. Yeah, I have it. I have the interface. So I need to deinitialize my swap chain here. Renderer deinitialize swap chain. Let's see if that fixes it. That does not fix it as I would imagine. Because what is actually the difference? It is just telling me that I'm doing an unsafe remove. Maybe if I first had my, where is it? So let me find my swap chain member here and let's figure out what the order of construction is. Order of construction as well as order of destruction, which is actually the reverse of the construction order. Okay, that is my swap chain pointer, and that is my swap chain semaphore. Let's first construct a semaphore, and then we would be destructing it last. Again, I don't know. I don't really know what to do about this. I do not know. How are they actually handling this? Let's go to the main example. So my problem at the moment is that remove pipelines and then you remove the swap chain and render targets. Huh. Wait queue idle. Maybe that is the thing that is happening there. I should wait for the queue to be idle. Huh. Subchain is for double buffer. Yeah. We're actually using triple buffers here. Uh, I don't know why they have three buffers, and as it seems, they don't even have those buffers in D3D11, as the next image call did nothing in D3D11. So yeah, this is actually handling the double buffering, drawing on one buffer and presenting the other. But again, this function does nothing on D3D11, so I don't know. That is the theory, of course. I'm quite sure that that is what they intended to do. But why it does nothing on D3D, I don't know. D3D11. So yeah, I figured out my bug here. My bug is that I am not waiting for the queue to be idle. So let's see our relations here. So if I'm going to main actually change these variables I have, like release them, reload them, whatever I want to do, I need to make sure that this queue is actually idle. Where's that queue? That graphics command queue. So that is one relationship there. So everything here has a relationship with this graphics command queue. How would I model that? And then we have this graphics commands, that is that thing. So that is the part that things get kinda weird. I think that should be I think that should be be an interface for me. So I would just provide an interface for the user to query whether the renderer is actually able to release its resources. Maybe that is what I should do. One thing that I'm sure I should do is actually do that wait on destruction. So we do need a destructor here for that command. So for the renderer's destructor, this is not good to write your own destructor here because it is going to actually cause cost us the move operators. We would need to write our own move operators. So at the moment our renderer is actually movable. But if I were to write a destructor, that our renderer wouldn't be movable anymore. So let's figure out something else. I'm thinking about, so one thing we know is that this should be destructed last. Okay, so that is why it's being constructed the first. Alright. And I think the command pool would be destructed even later than this, because this is using that. So let's see here, command pool PDR, command pool, and then no, so it's the other way around, but why? Why does the pool depend on the command queue? I don't know. That is another weird thing we have here. So maybe, so here I would need, at the destruction of this, I would need to wait. So I'm going to add an abstraction here. That is going to be struct graphics command q. So what would this do? This would this would have those in it. So there would be a Q pointer and there would be a pull pointer. And then it would have, let's make this class here to make our access qualifier private by default, and then we would write a getter here. Public. The only public interface that we're going to have is okay. Yeah, it would be our constructor here, and then we would be writing a destructor. So that is what our destructor is going to do. My destructor is going to wait on the Q pointer. So that is this wait Q idle. How many nested classes do you have? Yeah, I have a bunch of nested classes. I'm just trying to like uh, make my classes scope as small as possible. So if this class is going to be used only here, only in this scope, I'm going to limit the scope. Why would I expose this class to anyone else? So that kind of simplifies the code. The user is going to simply see this class, nothing else. The rest of the class is just for me, for my own use. The user doesn't have to actually know about it. So I'm going to wait on the Q idle here, qputter.get. So that makes our sorry about that. That makes our destructor safe. However, this is still not enough. I would also need to provide this what would I do here? Void wait for Q. Wait until Q is idle. That would do this, and I would do that here. That would be const there. Sorry. Now we just need to get our constructor correct. And that is going to be simple. Type graphics, blah blah. So I'm just gonna copy paste this part, put it down here, just rename everything. And now it's time to actually write our move operators, because we're not going to write them all over again, but we're going to set them to default. Then our move assignment, same is it is default again, and that would be it. So yeah, and now we would just have this command queue. However, we're still missing one more thing, and that would be remove command. Okay, that is Q pointer. So that is going to be get Q. Get Q. That is kind of bold actually to provide a type called Q with capital Q and not put it in an interface, not put it in a namespace. Like many other people are going to have Qs. What are you going to do about them? Okay, that is so that we can actually later on use it as we do use it. So we're gonna put it here. Graphics command Q, graphics command Q. Okay, that's going to be default constructed as signified here. And that'll be it, except that we're going to have some issues as to where the heck these are, and these should be changed. And what that would be changed to would be get command. No, get Q. Get Q. Okay, I believe that is going to work. Let's compile this and see if it works. Someone disliked my videos. It doesn't. well, maybe my videos are bad. Who knows? I do not promise that my videos aren't bad. My videos could be crap. Okay, what was my error? My error is that I'm missing something. Okay, I'm missing a column here. And then okay, remove that one. Okay, and that is not public, that is public. That works. Still okay, the undeclared variables. I know. I thought I renamed these. I changed those. I thought that was the case. Seemingly not. Oopsie doo. Cannot convert from initializer list to command descriptor. Why would that be? Is the interface not get Q? It is get Q. Have I mistyped it? No, that is correct. Graphics command Q. That is the same as that. And what is the problem here? Oops, it gets an access to pool rather than the queue. Okay, that is interesting. So what were we doing previously here? Okay, that is pool. That is right. That is pool there. That is even weirder. Oh god. Kill me now. Why are we using the pool? Okay, I guess I'm going to expose an interface for the pool as well. But I don't know why that would be. Get pool. Interesting stuff indeed. Why would you need the pool? Where was the code here? Let's Interesting. So graphics command uses the pool. However, the queue itself uses is where's the queue use? I don't know. What would this be saying me? It would say that it does not know about the render. Then I would also need to actually properly call this in the constructor here after that. And comma there. This would be my input. That should do it. It didn't. No operator default constructor available. For what? Graphics command queue. Oh yeah. For God's sake. I typed the. Let's do that. And we should be done. Come on, all the compilation errors. Be done with it already. Overload that takes 3 arguments. Overload of what? What is wrong with me, really? I am doing the wrong thing all over. Let's see. Let's see that. Maybe they have the right to dislike my videos. Graphics command is not a base member. Who said it was a base member? Okay. I would need to add a space there. Come on, compile for God's sake. No, no. What does this one say? Cannot convert argument one from. Let's actually take reference. Okay, back to sanity. We compile. It works. It doesn't. Wait for idle. And that would be because I am waiting for idle when this is null. Let's check this code. That should work. And we are almost at the 1 hour mark. That works. This still doesn't. And understandably so. So I kind of have to in some way signify that all these are actually dependent on the command that they are used with. So how would I go about doing so? How would I do that? Let's want to simply add an interface here. That is gonna wait for hardware to release the resources, and that would call the graphics command wait some nope, not like that. No, that was correct. Wait, but why does it not work? Come on, IntelliSense. I remembered Visual Studio's IntelliSense to be good, but it is just awful. Wait until Q is idle. Okay, now what I need to do is whenever that I am whenever that I am going to do these kind of things, I would wait for the I'm gonna wait for the hardware to release my resources. That is actually not that bad of an idea here. Let's see. Let's see if that works. Not there. Not there either. I'm going to copy these error messages down here. This one is missing error messages. Again with this. Update no, it doesn't want to. This needs. That needs it too. This needs it too. Same with that. I think that is it. I think this is going to work now. Yeah, just like that. Oopsie doo, however, here still on our destruction we have a problem. And that is correct. That definitely is correct. That is correct. This isn't doing the job. So our order of construction and destruction is not doing the job for the queue. Let's see if it is actually possible to handle this with that. Maybe my swap chain could go make sense and see how they code style files function naming etc. You need to check out NVIDIA samples. Yeah, I do need to check out NVIDIA samples. I'm currently just trying to figure out this engine. Uh, I kinda have some experience with. I have plenty experience with code design and actually code styles in general, not in graphics. But yeah, that definitely helps to check out NVIDIA samples and see how they actually code. But this series is just focusing on the Forge engine and trying to understand their code, trying to improve their code. It definitely does help to take a look into NVIDIA's examples. So what I'm going to do here, I am going to actually do that. So my graphics command is going to be the first thing that is going out and the last thing that is coming in. So I think that is the correct dependency order. Like every single resource that we have in our renderer is dependent. The queue is dependent on them. The queue is operating on these resources. It is rendering to these render targets using those pipelines, root signatures, and whatever. So if anything is going to go out, this should be the first. And actually, there's one more thing to do here, and that is graphics command. So the graphics command would also need to wait on these fences on destruction. I'm also going to wait for this command to actually put whatever it needs into command queue. So that's another destructor that needs to be written here, and that would be the body of that destructor. Me just waiting on this fence splitter. And the name of our destructor is of course the same with this graphics command. Blah blah. There goes that. And I actually don't. Yeah, I want this to be mobile. So let's make let's declare our move constructors, destructors, operators. Operator equals, and that is our move assignment, which is defaulted. Let's try this code. I actually don't want the user to. Alright, what is that? Fence. Get fence status. Null footer was sent as fence status. As to get fence status. So yeah, that is correct. This actually could be null. Alright, we're back to sanity here. I believe. Okay, let's cause the crash again. I believe this is a resource loader just telling us that I'm not freeing those resources. How can I actually get it to show me the error? Yeah, here. Okay, I'm happy with that. That is just telling me that I am not freeing any resources that I've gotten from the resource loader. So we fixed our runtime bugs and we are 12 minutes over time. So yeah, thank you for watching and we will continue on this. So tomorrow I will probably just redesign the whole thing and then I would change my abstractions accordingly just to make sense of what is happening here. We've learned a lot right in this example, so there's a lot to change and I will start applying those changes from tomorrow. Thank you for watching and I'll see you next time.